Today I'll explain binary search in simple way. Before understanding the binary search, let's check why the need of binary search. So consider I have a array 1, 3, 5, 7, 9. So if I want to find the 9 in the list or array, I have to check each and every element, like whether 9 is existing in the not existing or not. This might take time for execution, and I mean the CPU time will be taking more. And this approach is usually called linear search. To solve this entire problem faster, we use binary search. Let's come to binary search. Like binary search will work on sorted array and will reduce the search space by half every time. I mean, by looping that. Let us come to the idea of binary search. Let's say I have to find the target as 7. We will get the middle element. Like here, middle element will be 5. So we'll compare. For example, if the middle equal to, sorry, the middle equal to target means we will find the target. We usually find the target. We found the target. Okay. If middle is less than target means instead of moving from every, I mean, we'll have the moving concept, I mean, index position to move from left or right. Let's say we'll take left as 0 in this indices. Obviously, right will be, we'll find the array, right? And in that array minus 1, array dot length minus 1. So, if the condition mapping like middle is less than target means we should come, yeah, before going to that, I'll explain why we need sorted array. Let us understand why sorted array. See, before I told binary search works on sorted array. That means, let's say 1, 3, 5, 7, 9. This is the array. So we know if 5 less than 7 means we should go after that. I mean, we can compare 7, 9, right? Instead of going back. Means we know that sorted order, if it comes sorted order means smaller values will be left side and greater values will be on right side. Okay. So this is the main core thing for the sorted array. If I have array like 7, 1, 5, 6, 9, and I have to find out the sixth element or 9, 9 target, we cannot find. because we didn't know the direction. And it will take time to execute. I mean, it will become like linear search only if we do that. So binary search initially works on sorted array. Means even if array is not sorted, we must convert that to sorted array and do the operations. By this, you may understand the sorted array reason I have explained, right? So we'll go on to the algorithm. Here I didn't mention the middle. Generally, middle means what? By 2 and divided by 2, whatever array is, it will get the same of middle element. So we have to find out the middle position basically. For that, what we must do? Middle equal to left plus right. Right. This will give me the middle position. Okay. So as we talked earlier, middle equal to target means we count target. If middle is less than target means we must go forward. To do that, we must cross the middle, right? So instead of checking, I already know that 5 less than 7. We must go to 7, 9 elements only, right? For that, I must cross mid. So to cross mid, we have a directional which is called left. So if left position equal to mid plus 1, got it right? We'll go from mid and we'll compare again. Left will be mid plus 1. Yeah. Directly it will go on 7. And again it will find out 7 equal to 7. Likewise it will go. And in that case, it is middle greater than target means vice versa. Here we are at the right position. We must go back. That means middle minus 1 only, right? Right will be middle minus. That is the main core thing of binary search. So we will implement all the process as a program. Writing JavaScript as a much lean onto the JavaScript. You can select any language. There is nothing wrong with that. But basically the logic will be same in every language. Okay. So we'll start binary search. I'm taking a function of array. Initially what I told fonts, we must convert array to sorted, right? For that we have a sort method in JavaScript. And we can take so it will plain method sorting. Okay. Then we'll write the while loop. But before that, we must have what should be there in the condition. Let let equal to null. I mean it is the index position, right? Let right equal to that result dot length minus 1. Okay. And then I'll compare while f less than or equal to right means we must do the operation what I have told before. Okay. Now before that, as I said before, let we must find out the middle one. Middle equal to math dot slope. I'll explain why we are using math dot slope. This concept remember already before. So left plus right by, let's say if I got 3.5 or 6 as a middle, I want only the numeric words. For that, I use math.pub, nothing else. Okay. Here comes our main one. We must have a target, right? But target equal to minus. And here is result of middle. Here result of middle means what? We are getting the middle position element, nothing but. Okay. Is equal to target. Why I have written equal? I mean, I'm using strict equal. It doesn't take for a string or anything. It must be equal to that number. That's it. Then we are simply returning the mid. Okay. Else is what should be before I told you, right? The result of middle what less than target means. Remember I told you, right? If the array is in sorted order and if the middle element is less than target means we must go right side. For that to go right side we must cross the middle element, right? So we have a variable left equal to middle plus 1. Nothing but left position may be changing to 1 position from mid. That's it. Yes. Doesn't matter if you mention the condition or not. Directly it will take that outside condition of equal. I mean that else. Directly I can mention return equal to middle minus. So I have written up to this while loop. I mean up to this while condition it will go on executing the thing. What if left greater than right? That will be other case scenario, right? For that I'm just returning minus 1. Function must return one function, right? Either it could be the value or any result. Then only that function will give me the result as an output. Otherwise it directly give me the undefined. So for that I have written the minus 1. That is about the coding part. We must execute whether it is working as expected or not. Okay. I have implemented the whole idea of binary search here. Okay. We have implemented the entire idea of the binary search, and binary search works on sorted array, right? We must get the sorted array before doing all the operations. And here in my function, we are converting that into sorted array and doing things on that sorted array. It looks like awkward. And also here, if you see result, what is result? It is looking the naming convention is awkward, right? So instead of that, we'll see the other approach. Before going to the binary search, we'll convert the array. Let's name it as array. Okay. And array dot sort of array. Whenever there is a result, I will rename it as array. Okay. We have renamed the entire result as array. Okay. So looks like we have completed the entire thing, like giving the operations and checking the condition, writing the middle, and positioning the left or right based on the condition. If the nothing happens, we'll return -1 exactly. So we have completed this. Let's execute this. Console log. To execute in the JavaScript, we have a console.log like print in Python or system.out that will tell in Java. So we'll execute this binary search and same array will be there. Target would be 9. So it will give me the target position in the array, like fifth position, fourth position or something. We'll check whether it is working as expected or not. Okay. To execute JavaScript, we have node binary search dot 0, 1, 2, 3. We have found the ninth in the fourth position. That is returning the same. I think we have completed the binary search. So that's all about the binary search. Thanks for watching. Please do like and subscribe for the more content. And it will give me more motivation to do like this video. Thank you.